All right, I'm going to start with this far away shot just so you can kind of get a perspective. You'll see that my case is kind of there in the middle. There's my guitar, there's my desk, here's my room space, kind of my workspace for reviews and stuff. So let's look at my case design first and come in close here. So this is the general build here. So I've got my two front fans here, and there's dust filters. The dust filters are to help replicate what other cases have, because they'll usually have some kind of front panel or something. And B, I didn't want my kids sticking their fingers in the front fans in case they got around to it. Now, what makes this case really different right here is this. So this is two 200 millimeter fans, and the fan size really isn't important. It's this angle of this panel. And what this is allowing to happen now, I'm going to come back over here. And what this is allowing to happen is so this is what a gaming PC looks like. You've got your motherboard is where the motherboard's kind of in the back. Actually, let me just go ahead and, so I've got like an acrylic panel so you can have like a window and still see inside, because that's cool. And a lot of cases have tempered glass side panels, so I wanted to kind of duplicate that as much as possible. So this back part here's the motherboard, here's the RAM. This is a CPU cooler, CPU sits under it, and you got this big old hunk of metal to help keep that cool. These are graphics cards, and you can kind of see underneath there, here's the bottom of the motherboard. This is the ATX format. There's lots of different sizes. You could do just about anything with that. But yeah, so all of these things are to help, especially with these. You've got all this metal. This is a heat sink, and the fins and the fan blows air through it. Same thing's going on here. You can see the card is just this board up top, and then this big metal thing is all this is a heat sink to help get all that heat off this little tiny. There's a GPU chip that's right underneath there. You kind of see that little bundle. I mean, these GPU chips are like smaller than a quarter sometimes. So, and then you can kind of see underneath there's fans spinning, and they blow all this hot air through these fins, and then the hot air comes up into the case. Now normally, well, we'll talk about normally. So you've got hot air coming out the back side here of this CPU cooler. You've got hot air coming out the sides here of these graphics cards. So what's happening is I've got these front fans here pushing the hot air towards right through the case, and then instead of having to make any twists, turns, bends, 90-degree angles, we do have a slight bend. These two fans are exhausting that hot air, so we have just a straight through flow. Now, as you can see where my graphics cards hook in? This is what they call the PCI slots. And you can see that my metal panel just ends right there. I cut this metal panel down, and so if we come up top, you can kind of see right here, the metal panel ends right there. And so this thing has been like cut almost in half, probably like a third of it's been chopped down. And then instead of putting fans in the back like our traditional, we've got our fans here. And so if we come back here, I forgot to get a DisplayPort cable. If we come back here, you can see it again. See, there's that chopped down panel. There's just enough room for the graphics cards here to fit. And this is where you'd plug in all your cables. And even this little port here that's all the way at the end, there is still plenty of room. I was able to plug, I actually had to use that port when I tested, because my monitor was a DisplayPort, and it worked fine. I was able to plug in no problem. Like, I didn't even touch or have to worry about the fans. If there's just like a little bit of shielding there, that would protect it, but you know, this is a prototype. So that makes it completely unobstructed. And what it also does is it allows space up top and underneath the cards here for air to travel through, so that you have a continuous airflow, so it's nothing, so everything has plenty of room to breathe and get fresh air. Now, another key design element here, so you notice I got this fancy weird angled panel thing going on. I was able to put my, well, there's my cat. So I was able to put my light up power supply, and a lot of power supplies now have RGB, like multicolored fans. So we'll talk about traditionally what happens, but yeah, what this does is this allows this to also get really good airflow. Now there's other cases that do it, and they call it dual chamber. But I've got, you notice how I cut these parallelogram panels and then put them together to make this angle. And I thought it made the case look better. And it's something I've never seen before in a case, is that angled panel as well. Now, they call this a dual chamber design. There's cases that do it even though they just keep a straight box. But this dual chamber design actually does focus on the airflow. So that power supply, let me pull this guy off now. So this is what the power supply looks like inside here. See if we can see inside there a little bit. I'll have to pull off so I'll pull off this whole panel here. Sorry, I know this is going to be a little obnoxious, but I had to, there we go, I got a hold of it. I use Velcro strips to kind of hold my panels on because, you know, this is all plastic cardboard. It's great for making a cheap prototype though. All right, there's the power brick. So this thing is just this giant box, and it can really obstruct airflow. So by getting it away from all the internals there and putting it on its own side, because it has its own every power supply has its own cooling fan, some very, very minor exceptions that are for like, they're not high power. But yeah, this is a 1,000 watt unit, and so one of the things you'll notice here is you see this how it goes straight and then cuts in. That's to make sure we have plenty of room for a long power supply and the cables that stick out, and then still be able to close the panel with these. And also, cable management is super important, but not everybody does it. Sometimes they get lazy and they just throw their cables up across the motherboard and stuff. But because the power supply is on the back here like this, it will force users to route their cables in the back. They don't have any choice. So this whole build encourages the optimum airflow. Now, of course, when I tested, I didn't hinder myself in any way, but this is just kind of another design perk. So the other nice thing is, if you're looking at the side of the build, you're not going to see all the cables sticking out because of that back panel. It kind of hides them a little bit, but then you can still easily access and plug everything out the back, which is the way that most cases do. Now, that pretty well covers what this design is. Like I said, the main important thing is this angled panel this isn't anything anybody's tried, and I've never seen it before, and it helped me straighten out my airflow to the best degree possible, to where I had the best temperatures. Oh yeah, and the other thing is that you could try to do fans on the bottom and fans on the top and have straight airflow this way. So it's just going like from bottom to top. In some case designs have tried that, but there's a chimney effect that ends up being very detrimental. So that means all the heat that comes from this card gets pushed up to this card, which then gets pushed up to the CPU cooler and RAM before it exhausts. So this heat just builds up and it just flows up through everything. Here, the flow helps keep the heat separated. I mean, obviously you probably can't like 100%, but my temperature graphs prove that it worked because it keeps the heat separated enough that now, even in a stress gameful mode, this CPU cooler doesn't get heated up. Keeps temperatures a lot lower on the CPU, which can allow it to boost better. So a lot of CPUs have auto boost now, and that auto boost is dependent on temperature. CPUs have an internal thermal thing. So that's how my case works. Now, just so you can have a comparison, this is more of like an average kind of mid-range budget gaming case. The power supply, you can see that little blue connector, that's the power supply. It's here on the bottom. So you see why I moved the power supply out from there. Because if I have this block down here, it's really hard for me to get the airflow. Most cases have one exhaust fan in the back, and otherwise they have the exhaust fans up top. Now in this case, this is only a 120 millimeter fan. The biggest I've ever seen a fan get up here in the back here is like 140. And if I've ever seen anything different, it's way weird cases. Like they're just completely unique designs that are usually more aesthetic than that. And so this fan is about all that you get to exhaust out the back. It also has to pull all this heat from this graphics card out. So there's a single card system, but you can see the airflow is kind of the same. Now this is a liquid cooler, so I've got the radiator in the front. But yeah, in general, what would happen here is you'd be, if you had air coolers, which are more popular than liquid, you're exhausting all this heat up through here. And you've got this problem because the fans aren't angled right now. Just to show some similarities, here's, move this panel out of the way now again. So, there it goes. Some lighting cables, but, so as you can see, this case has the same kind of setup as mine. We got these two giant 200mm fans, and as you can see, there's a dust filter. So that this makes the airflow very similar to other cases like this, but this is, well, it's becoming more common. It's not like super common, but this is what you'll start seeing in higher end gaming cases. So you're going to see that the fronts are going to be similar in these cases, and I just don't have all the fancy paneling that other cases will have. But you can see that all that extra airflow gets restricted right here in the back because there's not equal amounts to pull. And so the case heats up. Now this is actually even worse case scenario than what I tested. Here's the case I used to test. And so, same kind of scenario here. So I think you get the idea of the panels. There's dust filters and stuff, but there's two fans. Now what I did in this case, this was my best case until I designed my own. This was the best case I'd ever bought for temperatures. But I had to add some stuff to it. So I added this fan on the bottom. As you can see, there's a problem. I've got these two fans flowing in two different directions, which is just interrupting the airflow. It does help with keeping the graphics card cooler, especially if you have a single one. But once you put two cards in there like my other system did, or if this card was a super high heat one, the airflow gets interrupted too much and the heat starts building up, and it starts building up through all the other components. And that's just the problem with cases. And you can see I've got intake fan, intake fan, intake fan. And then here I've got an exhaust fan, an exhaust fan, and an exhaust fan. So there's 6 fans in this case trying to get the heat out. But because everything's in different directions and they're perpendicular, this is not airflow. It's like spraying a hose against a wall. If the water hits directly in the wall, it splatters everywhere. Well, that's what's happening to the air. Everywhere it's hitting each other, it's splattering everywhere, it's creating turbulence, and it just causes the whole thing to heat up. And so I tested using actually this is the CPU cooler I ended up using. And you can see this is a 140mm fan, so you get a little more out the back, but not much. So here's the big difference. See these graphics card slots, same width as right here. But now, see all this extra paneling here? Look at this. Like, this is a spot that's meant to exhaust heat. And if you put maybe some like really tiny fans on here, you could do it, but tiny fans are noisy and they don't blow as much air. So this ends up being just wasted space, and it doesn't do a very good job. And then, as you can see, when I cut my case down the side, you can't fit a fan in the back anymore. This is a huge deviation from normal cases. Every other case has this wider panel that's big like this. Mine's is cut down to like that. So I have to have the angled fan. Now, you could probably do it where you could do like a smaller fan up top and then just do an angled cutout here at the bottom, and it'd work too. But this angled panel is just so important to the utility. That is what makes it work, is the angle, versus this, every case has this kind of flat design. So I think, as you can see too, this if we look at the size comparisons again, so my case would be considered premium because of performance, and it sizes out about the same size as like a normal, kind of like a mid-tower type case. That'll work. That case is obviously, though, a lot thinner than mine because it doesn't have the dual chamber. But so this one still would be a little bigger. But then when you compare it to the monstrosity that's one on the back, like you can just see how much bigger that case is. It's just so tall and huge to accommodate all those fans. This is a very high-end case, and you don't see many like this. So the fact that I could take that's probably the best cooling you can possibly buy on the market right now is a case like that. I've never seen anything really work better. And and this thing just completely dominated it and destroyed it. And they all have the same blue NZXT fans, so it was very easy for me to get a apples to apples comparison. Of course, I had to move my entire system out there. I did use those graphics cards for my temperature testing with that CPU cooler over there, so I've had to move things back around for my review work and stuff. But that is what was happening. So I think that covers everything really well. This case design, obviously, I'm very, very excited about it. But yeah, that temperature thing was just, oh yeah, and that was the other thing I was wanting to point out. The other thing that's nice though is because I designed this with panels like this, I also see this as being hugely manufacturable. Like it won't be as easy as just a straight box, but everything is like triangles or rectangles or parallelograms, and so to actually have to manufacture a case like this, well, it would take some redoing of some manufacturing. I'm sure it would be, I think, very feasible if it was as easy for me to piece together using just, you know, scissors and cutting these into basic shapes. So I feel like this is also something that is very manufacturable. So it's still not like, it would be like, oh, well, it worked better, but nobody would ever be able to design it. And I don't see that being a problem with it. So yeah, airflow, here's the keys, the biggest thing. And I mean, you guys are engineers, you probably know all this, but just in case, air does not like to change directions. It has to be forcibly changed. And so if you expect air to come into the case straight and then just magically curve up and go out here and stuff, go out the back through this and go up straight, that's not what's going to happen. All this is going to create resistance. Air is going to stop moving. This makes the airflow as straight as possible while still making it not have a chimney effect. And I haven't been able to think of a better way. So I'm going to call it at that. So let me know if you have any questions, and I hope this video helps.